Wa alaikum assalam, habibtis. Oi, check this. Man went for a little jog this morning, car. My skeleton was moving weak, so man needs some extra calories. Now, en route, man sees Bill Gates and Jeff Bezos on the streets. So man was ready to swing my sword like I swing my shellong every night, cuz. Now, as I'm chasing them down, Bill Gates tries to back out his laptop and hack into my skull. So man had to give him the one happy slappy. Now I see Jeff Bezos trying to hop away like one kangaroo. So man had to unleash my kung fu abilities and I fly kicked him straight in the stomach. Then man had to fly out, car. Man just got released. Anyways, look, let's jump straight to this. A little light work thing as usual. Man's gonna take difficult and make it into a little simplification. So give me a sec. Let me drink a little something. You don't know the pattern. Let's see what's this popping right now. Okay, a little something to get me started. So, let's take a look at what's going on here. Okay, so basically, let's understand what's going on. Firstly, we're looking at integrating using the reverse chain rule. Okay, so this is one topic, you understand? So let's go through this slowly, yeah? When you see a question like this, the first thing you're gonna do is you see these numbers. Whenever you see a number, let's say if it was 2, 10, 20, 30, 40, the first thing you're gonna do is you're gonna take that 2, you're gonna put it on the outside. Okay, you're always gonna do that. Then man's just gonna rewrite x plus 7 to the power of 9 dx. Okay, cool. Now. I need you lot to stay focused, okay? Because these steps are going to be really important, you know, the harder the questions get. So you need to fully understand what's going on now. So later on, life is going to be a bit more simplification. You get me? So listen up. Basically, what you need to understand here is this is really important, what we're doing here, yeah? So basically, what this means is we're integrating in respect to x. Now, in respect to x to the power of 1, for example, okay? So there's an invisible 1 there now, yeah? So if you look at this question, normally, forget about using the reverse chain rule, yeah? Normally how people would integrate this, if they could, what they would do, yeah, is they would do x plus 7 to the power of 9, yeah? So they'd have to do this to the 9 times, you get me? They'd have to write this out 9 times. You get what I'm saying? And then what they would do is they would multiply out until they have some madness, blah, 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 and then they would integrate, okay? But listen, that's too long for us, you get me? We're not going to do that. We're going to go through the easy way, yeah? Now, I'm going to show you the steps. The first thing you need to understand is, before I show you this rule, because this is to the x to the 1, and it's the only x function here, okay, for example, what I mean by that is, let's just say if there was a 2x on the outside, what I'm showing you wouldn't make sense, okay? It will actually wait, yeah, it will make sense. Listen, you need to stay focused, yeah? So what I'm showing you right now is a bit different compared to if there was another x function. Now, because this is x plus 7 to the power of 9, and we're integrating in respect to x, these are the following rules. Now, these rules are very consistent even when it comes to the reverse chain rule. This is basically the reverse chain rule, but this question right now, what we're doing here, is very simple, so you're not going to see the beauty of this rule, you get me? Right now, you're just going to see a little layer work thing, so let's jump straight into this, yeah? So basically, what you do is I'm going to rewrite 2, and then this is the first step. Actually, let me write down the steps. The steps are better. So step 1 is you're going to rewrite the inside brackets. And what I mean by that, whatever's on the inside in it. So rewrite the inside brackets, yeah. Step 2, yeah, you're gonna add 1 to the power. Okay. Step 3 and step 4, you're gonna times by 1 over the new power. So whatever the new power is, yeah. And you're also gonna times by 1 over the derivative of the inside. So what happens when you differentiate the inside? So the derivative of the inside. Now listen, we're going to go through this so you're going to fully understand what's going on. You understand? So remember, step number 1. So this 2, man don't care about the 2. Man's going to leave it on the outside. Cool. Now let's jump into this, yeah? So step number 1 is telling me rewrite the inside. So remember, this is the inside. X plus 7 is the inside. So man's going to write down x plus 7. Step number 2 is telling me add 1 to the power. If I add 1 to the power, 9 plus 1 is telling me 10. So man's going to add 1 to the power. Step 3 is telling me times by 1 over the new power. So the new power is 10, obviously. So man's going to do times by 1 over the new power, which I've told you is 10. So man's going to times by 1 over 10. This next step is telling me times by 1 over the derivative of the inside. So times by 1 over the derivative of the inside. Now listen. What happens when I differentiate this? So remember, this is inside the brackets here. So this is the inside. What happens if I differentiate x plus 7? Now listen, if you don't know the answer to this, man's going to have to come there and give you the one happy slappy. If you differentiate x plus 7, if you differentiate that, it's going to give you 1. So I just times by 1 like this. Then you close off the brackets. and you put a plus constant. Don't ever forget the constant, okay? That's a necessity in these types of questions, okay? Once you do this, little light work thing, all we do now, 2 divided by 10, that's going to become 1 over 5. So man's going to write 1 over 5, and then you're left with this x plus 7 to the power of 10. And then plus constant. And that's it, you get me? This rule, listen, you need to remember this rule, because this is the rule we use throughout all of chain rule. We use this rule throughout all of the reverse chain rule, okay? Keep that in mind. Okay, cool. Now let's go to the next question and see what it's saying. So let me just rub all of this out. I think there's an easy way I can rub. So remember the rules. Make sure you write all this down. Pause the video, copy it down, because then I'm going to rub all of this out now. All right. Yeah, that's good still. Let me rub this out. Hang on a second. Hang on there. Okay. Oh, shit. What happened? Yeah, nothing happened. Okay, cool. So let me write down the next question now, yeah? Let's say, for example, if the question was telling me something like, don't go anywhere. Give me 2 minutes, man. Let's say if the question was telling me something like, integrate, 4x cubed, inside x to the 4 plus 3 to the power of 5 dx. Okay, now let's focus on this question for one moment, yeah? Now, let's focus on this here. Let's focus. Now listen up, yeah? Why is this question so special? You might be thinking, you might be looking at this and saying, this question's looking delicious. You get me? Now you need to be questioning and saying, what's wrong with this question? Why is it such a special question? And why is it related to integrating using the reverse chain rule? Now man's going to explain. Now, this here inside the brackets is the inside. It's the inside because it's inside the brackets, okay? So therefore, if this is the inside, okay, therefore, this is the outside. Okay, now that we've clarified what's going on here, man's gonna rub that out now. I just wanna make it clear what I'm talking about when I say inside, outside, outside, inside. You get me? So you know what I'm talking about. I don't want you lot thinking I'm talking gibberish. Now, let me explain why this question is so important. You've got 4x cubed here, yeah? You've got x to the power 4 plus 3. Now, my question is, what happens when you differentiate the inside? What happens when you differentiate x to the power 4 plus 3? You get 4x cubed. Now, it's not a coincidence that 4x cubed is on the outside here, and also when you differentiate the inside, it gives you, the derivative gives you 4x cubed, which is on the outside. You get me? This is not a coincidence. Now listen up, you need to, before I carry on, this needs to be very clearly structured into your skull, fam, you get me? Because what you need to understand here is when you're looking at these types of questions, the first thing you need to say to yourself is, what happens when I differentiate the inside? What happens when you get these types of questions? You say, if I differentiate something in this question, is the derivative of that thing I differentiated also in the question? Now what I mean by that, I mean if I differentiate x to the 4 plus 3 and I happen to get 4x cubed, it's not a coincidence, you get me? Now, there's also something else that's really, really important you need to understand. And what that is it doesn't have to be exactly 4x cubed. For example, even if you got 2x cubed, even if you got 7x cubed, even if you got 123, 4, 5, 7, 80, whatever it is, x cubed, this rule still counts. Because the main thing here is you get x cubed. I don't really care about the 4. Fair enough, it was nice getting the 4. But what's really, really important is that we get the same thing. We get this. We get the x cubed. That's what's really important. Because at the end of the day, that's what's going to cancel out. Now, let's go through this and I'm going to explain, yeah? So remember, the first thing you say to yourself is, okay, if I differentiate the inside here, is sitting on the outside, therefore I have to use in the reverse chain rule integration thing, yeah? And these are the steps. The steps are exactly the same steps as we went through in the first question. However, there's a minor difference, okay? Now, man's gonna walk through that difference now. The first thing you do is you're gonna rewrite 4x cubed. No one gives a shit about 4x cubed. Man's gonna write down 4x cubed here. You get me? Little light work thing. Once you write 4x cubed, what we now do is we integrate this, okay? Now, you're going to see why we don't touch the 4x cubed. We only touch this, so we integrate this. This is what we integrate, okay? Now, watch this here, watch this. So, remember the steps. What I need to do, the first step was, if you remember, we wrote down the steps earlier. The first step was, I rewrite the inside, so I rewrite this. The next step was, add 1 to the power, 5 plus 1, 6. The next step was times by 1 over the new power. So 1 over the new power, and the new power is 6. So man's going to put 6. The next step was times by 1 over the derivative of the inside. So what happens when I differentiate this? X to the 4 plus 3. If I differentiate that, gives me 4x cubed. And then remember, don't forget the plus constant, okay? Now, please bear in mind that this is being multiplied, okay? This is being multiplied. Now. Let's see what happens here. As you can clearly see, this x cubed and this x cubed will cancel out, yeah? That was the main point for this question. This question. The main aim here was to make sure these x cubes cancelled out, okay? Really important for you to understand that. Now, luckily, as I said, the 4s also cancel out. That didn't have to happen. The main thing that had to happen was these x cubes cancelling out. Luckily, the 4s cancelled out. Thank God for that. You get me? Makes life a bit more simplification. Now, all I need to do is just rewrite this. So you got the 1 over 6, and then you got the x to the power of 4 plus 3 to the power of 6. And then, of course, as usual, you've got the plus constants, okay? And that's that. Calm. Listen, I hope you're understanding what's going on here, because it's really, really important. Okay, I really hope you're understanding what's going on here. Let's look at the next question now. We're gonna keep practicing these, and we're gonna try these out and just see what's popping. Yeah. So let me wrap all this out. Just to make my case strong here on how you don't have to have the 4, and all that matters is x cubed. Let's just quickly look at a different type of question that's a bit similar to what I'm saying. Yeah. So for example, yeah. Let's say if this was the question. Yeah. Let's say if it said integrate 7x, open bracket, x squared plus 1 to the power of 3. Okay, now listen. Why is this question so special? These are the types of things you need to be asking yourself when you're seeing questions like this. You have to say, what does this question look like? Why is it a special question? What rule do they want me to use? Blah, 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 blah. You get me? Now listen. Obviously, because you know we're going through the reverse chain rule, obviously that's going to be the rule we're using. So you need to stay focused. Listen. The first thing I'm going to do is I'm going to look at the inside brackets. Remember, this is the inside because it's inside the bracket. If this is the inside, therefore this is the outside. Okay, cool. So the first thing I'm going to do is, what happens when I differentiate the inside? When I differentiate x squared plus 1, I get 2x. Okay, now listen, yeah? Remember last time what I said? Fair enough, 7 and 2 aren't the same thing. However, they've both got the x to the power of 1. Because remember, that's to the power of 1. And this is obviously to the power of 1. Now, you don't see that, but it is what it is, yeah? So, that's what's really important. I don't care about the 7 or the 2. All I care about is the fact that when I differentiate the inside, it gives me 2x. And that x also happens to be here as well as is here. You get me? That's what's really important. That's what we're looking for. The 7 and the 2 are irrelevant. Man, don't care about the multiples. All I care about is the variable on the outside, which is x to the power of 1. And when we differentiate the inside, we happen to get x to the power of 1 as well. Okay, cool. Now, let me rub this out quickly. Give me a second. What I'm going to do now is man's going to explain. So remember what we do is we rewrite this on the outside. Man don't care about the 7x, okay? But then what we do is we integrate this thing here as we did the last time. So remember the steps. What man's going to do is man's going to rewrite the inside. So man's going to write x to the power of 2 plus 1. Add 1 to the power, 3 plus 1, 4. The next step is times 1 by 1 over the new power. The new power is 4. Times 1 over, what was it again? Oh yeah, the derivative of the inside. So if man differentiates the inside, I get 2x. So man's going to put 2x. And then remember the plus constant. Okay, that's really important. Okay, now listen. What happens here? You can clearly see this x and this x cancel out, which is what we need to happen. This is the main aim of what we're trying to accomplish. You get me, fam? Man just went to the Olympics, baby. You don't know the pattern. But listen, this is what's happening. This is what's meant to happen, okay? Now that we got that, all we're going to do is we're going to do a little simplification. So 7's on the top. Man's going to leave 7 on the top. 4 times 2 is on the bottom. That's 8. I'm going to put 8 there. And then we're just left with this. So let me just rewrite this. X squared plus 1 to the power of 4 plus constant. Okay, little lightweight thing. Listen, I really hope you're understanding what's going on here. You get me? And if you're not, just keep watching this till you fully understand. Yeah? Cool. Let me rub this out now. Now what we're going to look at is we're going to look at doing a reverse chain rule with exponentials and them thing there. So let me just rub this out. Give me a second. Okay, cool. Let's say, for example, yeah, I've done a video on integrating exponentials, but man's going to go through it again, you know, to fully put that in your skull. So let's say, for instance, the question was telling me, yeah, integrate e to the power of 4x plus 1, okay? And it said integrate this. Alright, cool. This is a little lightweight thing. There's no other functions. For what I mean by that, I mean, let's just say if there was an x squared here, it'd be a different story, yeah? But because this is by itself, how you integrate this, it's really important you lot know the different rules. So remember, the first rule we went from, the first rule just before these questions, is going to be a bit different when you're using reverse chain rule for exponentials. Now I'm going to explain, okay? So what you need to do here, these are the steps here. What you do is you rewrite this whole thing. So rewrite everything. Rewrite everything, yeah? Man can't even spell from. Rewrite everything, okay? Once you rewrite everything, that's the first step. The next step is you times by 1 over the derivative, yeah? The derivative of the inside. Now, the inside is the power here because it's the one in the brackets, yeah? So the derivative of the power, or you can say inside. Okay, it doesn't really matter, yeah? Alright, cool. So if I follow these steps, it's telling me rewrite everything, yeah? So man's going to rewrite this whole thing. So man's going to do e to the power of 4x plus 1. The next step's telling me times by 1 over the derivative power inside. So man's going to times by 1 over the derivative or power inside. So what happens when I differentiate 4x plus 1? I'm going to get 4. So I put 4 down here. And then don't forget the plus constant. So your final answer is just going to be a quarter e to the 4x plus 1 plus c. Calm, little light work thing. Now that we've gone through this, yeah, now let's go through how we would use exponentials. Yeah, let's go through how we would use exponentials in the reverse chain rule. All right, let me rub this out. Give me a second. Let me rub this out. Okay. All right. Now let's check this out. Yeah. Let's say, for instance, the question was telling me something like integrate 4x e to the power of 2x squared plus, let's say, 24. Okay, now check this out, yeah, check this out. Now you've got this 4x here, and you've got the exponential just chilling here. Now I look at this question and I say to myself, what happens if I differentiate the inside being this power here? Or just say to yourself, what happens if I differentiate the power? You get me? Or the inside, wherever it is. So if I differentiate the inside, let me take it a bit up here. If I differentiate the inside, so what happens if I differentiate 2x squared? It's going to give me 4x. Calm, now listen. It's not a coincidence that there's also a 4x sitting out here. Now remember what I told you. Even if it was 8x, it wouldn't matter. You get me? What's really important is this x and this x. That's what man's really trying to get into your head, fam. You get me? What's really important is when you differentiate the inside, this x is coming out and there's also an x sitting on the outside. That's it, done. When you see this, you say to yourself, okay, man's going to be integrating using the reverse chain rule, okay? Now, the steps, however, are not the same as the first question steps. The steps you use here are the steps we just learned on how to integrate exponentials, the ones we just went through, okay? So don't confuse the steps. For example, what I mean by that is, when you realize this, there's always one step you follow always, is the thing on the outside, you just rewrite again. Okay, always rewrite that. Man don't care about the 4x. You get me? It's a little light work thing. Man don't care about the 4x. However, the e to the power of the 2x squared plus 24, remember, we just learned how to integrate that, yeah? What we do is we rewrite the whole thing. Okay, man's going to rewrite the whole thing. And then man's going to times it by 1 over the derivative of the power. Remember, we just went over the rules. What happens when you differentiate 2x squared plus 24? You get 4x, my guy. You get me? Little light work thing. Then you close the brackets. You plus constant. Okay, now watch this, yeah? This is really important. Watch this. What happens right now? This x and this x cancel out, which is why we're doing this. This is the whole point. We're trying to cancel out the x's on the outside. You get me, fam, yeah? Now, luckily, as I said, the 4's also cancel out, but that was obviously by luck. You get me? As in, we don't really care. Even if they didn't cancel out, we don't care. The reason I keep repeating these things, I know some of you lot might be like, you know, why is this guy repeating it so much? The reason I'm repeating it so much is because the more I repeat it, the more it gets ingrained in your skull, and that means you make less silly mistakes. You get me? Calm. Once I've got this little light work thing, this is the only thing we have left. So man's just going to rewrite e to the power of 2x squared plus 24 plus c little light work thing. Okay? I hope this is helping. I hope you understand what I'm saying. Just for me to explain this one more time, even if this was, I don't know, like 12x, okay, it wouldn't make a difference because you'd still get the x's and the x's will still cancel out, okay? So it doesn't matter. I just want to make sure you don't fully understand that multiples don't matter. All that matters is that the x cancels out, which, as you can see, the x's are cancelling out, and that's the whole point of reverse chain rule. The whole point is whatever's sitting on the outside gets cancelled out, okay? All right, cool. So let me just rub all this out. You know what? Let me just, I'm thinking, should I just quickly do a random question, yeah? let me just bring up a random question to make you fully understand what's going on here, yeah? Because I don't want you lot to bug out, yeah? Let's say if we had something like, let me think, give me a second, yeah? Let me think. 1 second, 1 second. 1 second. Okay, let's say if I had 5x squared on the outside, yeah? And then I did e to the power of, I don't know, man. Let's say we had 6x cubed. Okay, something like this, okay? Plus, 24. All right, cool. Now, what I say to myself is, what happens when I differentiate the inside? When I differentiate the inside, man's getting 6x cubed differentiate that, you're going to get 18x squared. Okay, now listen up. Man don't care about the 5 and the 18. What man does care about is the fact that there's an x squared here and there's also an x squared here. When I see this, when I recognize this, I say to myself, straight up, reverse chain rule. Now let's go through the steps together, yeah? The steps are, remember, the first thing you're going to do is you're going to rewrite the 5x squared. No one cares about the 5x squared. Once you do that, all we have to do now is we integrate this whole thing here, okay? So remember how we integrate exponentials? We rewrite everything. So man's going to rewrite the whole thing. And then man's going to times it by 1 over the derivative of the inside. What happens if I differentiate this? We just found out it was 18x squared. Close the brackets. Put the plus constant. As you can quite clearly see, x squared, that's it. And then the final answer is just going to be 5 over 18. You get me? I hope you're understanding what's going on here. It's really, really important you fully understand what's going on here. Calm. Now, let's look for a last one. Now, listen. This last question we're going to be going through, yeah? I'm not going to lie to you. Yeah? Is the last question requires its own video, yeah? But I just want to finish off with it, just to warm you up a bit, you get me? Because what's going to happen is, this is the integrating using reverse rule part 1. The part 2 is going to come out soon, and then with that one, I'm going to be going straight into only trig, because trig is a whole different story. Let's say, for example, it says integrate 6x, yeah? Sec squared, x squared. Something like this. Okay. Now, listen. I don't want you to get confused. This term and this term is one term, okay? So, this is not, for a lot of people, this is not sec squared times x squared. This is not what this means, okay? Because I know a lot of people get confused. This is one thing. So, that sec squared, yeah? That sec squared, that x squared is within. This is one thing. These are not separate, okay? Okay, cool. Now that I've just got that out of the way, I just want to make that clear for some of you that didn't understand it or didn't know that. Maybe you did. I don't know. Who cares? Let's carry on. Now, what I say to myself is I look inside the brackets. This is inside the brackets. I say to myself, what happens if I differentiate the inside? When I differentiate the inside, I get 2x. Calm. So, listen, what's sitting on the outside? On the outside, 6x is sitting. Man don't care about the 6. Man don't care about the 2. What man does care about is this x and this x. Okay, now that I've seen that, man's gonna say to myself, reverse chain rule. Now the question is, how do you use reverse chain rule on trig functions? That's what we're gonna be going through right now. So remember, there's always one step. The first step is rewrite what's sitting on the outside here. Man don't care about that, yeah, you get me? So man's just gonna rewrite that quick, give me a second, 6x. And then man's gonna integrate this. Now how you integrate this is, basically what you have to do is, your first step is, integrate the outside. That's the first step, okay? So maybe I write this down, I don't know. Integrate the outside. And by the outside, I'm not talking about 6x right now. I'm not talking about that. I'm talking about this being the outside and this being the inside, okay? So integrate the outside, okay? Once you do that, rewrite the inside. So man's gonna rewrite the inside. And then the last step is times by 1 over the derivative of the inside, okay? Let me just write that down. Derivative of the inside. Okay, cool. Copy this down, and then I'm going to rub it out, and then we're going to go through the question bit one by one, yeah? We're going to go through it one by one. So, remember, we're just focused on this right now, okay? We're just focused on this. So, I'm going to rub it out now. Pause the video, copy it down, and rub it out. Alright, cool. So, let's say, for instance, yeah? So, remember, step number 1 was integrate the outside. Now, for you lot that don't know, obviously this is given in your formula book, okay? When you integrate sec squared, you get 10. So that's the first step. Integrate the outside here is going to be 10. Next step was rewrite the inside thing. So man's going to rewrite that. Next step was times by 1 over the derivative of the inside. So what happens when I differentiate x squared? I'm going to get 2x. Calm, little light work thing. Now, as you can clearly see, this x cancel out, which was the main aim here. So you got 6 divided by 2 is going to be 3. So man's gonna write 3, and then you got the tan, then you got the x squared. And then you got the plus constant. Don't forget the plus constant. Calmly, cool, light working. Listen, I hope this video helped on, on how to use the reverse chain rule. But don't watch that. More videos coming soon. Love.